This video is about multiplying and dividing rational expressions. Let's get started. We will start our discussion about multiplying and dividing rational expressions by going back to fractions, because the same ideas that are used with fractions are used with rational expressions. Okay? Now, for multiplying and dividing fractions, you do not have to have the same denominator. That's only adding and subtracting, so you have the same size of piece. Okay? Multiplying and dividing have to do with cutting up fractions, and so you don't have to have a common denominator. The way that you multiply fractions is that you multiply the numerators together, as in negative 5 times 1 is negative 5, and the denominators together, 4 times 3 is 12. Okay? Now, one other idea that does come into play is the idea of cross-canceling. Okay? You can cross-cancel when you have a common factor. Okay? So let me explain why we can cross-cancel so that you understand. Okay? So in number 2, I could multiply the tops together and get 56, and the denominators together and get 70. But then I will have common factors. So for example, I know that 7 will go into both of them. Okay, it goes into it 8 times and 10 times, but also 2 goes into it. 2 goes into 8 4 times, and 2 goes into 10 5 times. Okay, so instead of waiting until the end to then reduce the fraction, I can cross-cancel before I do that. Okay, so I can see the common factors in the numerator and denominator. So 7 goes into 7 one time, and 7 goes into 7 one time. I'm identifying common factors in the numerator and denominator. Okay. Similarly, 8 and 10, 2 is the common factor that goes into 8 and 10. And so 2 goes into 8 4 times, 2 goes into 10 5 times, and then I can multiply 1 times 4. 4 times 1 is 4, and 1 times 5 is 5. Okay? That process of cross-canceling common factors is really important for us as we multiply rational expressions. Now let's look at multiplying rational expressions. Okay? So in a problem like number 2, okay, I don't need common denominators. That's for adding and subtracting. Okay? But what I will do is I will first factor both numerators and denominators. Okay, so a squared plus 6a plus 9 is a trinomial. It's what we call the ABC method. I'm looking for the simple ABC method, where I'm looking for factors that multiply to be 9 and add to be 6. And that is 3 and 3. Okay, and in the denominator, a squared minus 9, that's the difference of squares. So I have a and a make a squared, and to get 9, I get 3 and 3, and it's the difference of squares, so I do plus and minus. Okay, times, in the numerator over here, right here, I have a GCF of 3. So 3 times a, and 3 times what is negative 9? It's negative 3. Okay. And then at the bottom, I have a plus 3. Okay, so that is factoring numerators and denominators. Everything that I can factor, I will factor. Okay. Second step is to cancel common factors. Okay, this is the fun part. So I see that I have an a plus 3 here, and then a plus 3 here. Okay, and I have an a minus 3 here, and an a minus 3 here, and then a plus 3 here, and then a plus 3 here. You must cancel one off the top and one off the bottom, okay? This canceling common factors is the exact same idea that we saw earlier with cross-canceling. Okay, I was canceling common factors in the numerator and denominator. It's the exact same idea. Okay, and the last step is to multiply the numerators together and denominators together. This one's really easy. In the numerators, I only have 3 left. And in the denominators, I have nothing, so it's kind of over 1 or just 3. So that entire, rational expressions multiplied together, all that simplifies to be 3. Let's do one more together, and we'll do number 3. Okay, I'll follow the exact same steps. I'm first going to factor everything that I can factor. Okay, so starting with this big thing, what I see is that there's first a GCF. Okay, so I'll factor the GCF of 2 and get x squared minus 5x plus 6 over x squared minus 4 is the difference of squares, so I get x plus 2 and x minus 2 times, now over here 2 plus x, the order is kind of backwards, and I can reverse the order because addition is commutative, and so x plus 2 and 2 plus x are the same thing. Okay, but the 3 minus x is not the order we typically write it in. And so I'm going to switch the order of them, but keep x negative. So I get a negative x plus 3. That's the exact same thing. I'm thinking about it more of 3 plus a negative x, and then using the commutative property of addition to rewrite that. And that'll be important because I'm going to factor out a negative in my next step. So I'm not done factoring. I'm going to go one more step in factoring, and I'm going to take care of this trinomial here and factor a negative out of this. So here we go. I get 2 is still there. Okay, this trinomial x squared minus 5x plus 6 is the simple ABC method where I have x and x, two numbers that multiply to be 6 and add to be negative 5 is negative 3 and negative 2. Okay, divided by, I still have my x plus 2 and x minus 2 times, and I still have my x plus 2. Okay, and then down here in the bottom, I will factor out a negative 1, okay, and I'm left with x minus 3. Okay, so I factored both the numerators and denominators, everything I could factor. I will now cancel the common factors. Okay, so the same things on top and bottom, the x minus 3 and this x minus 3, this x minus 2 and this x minus 2, and this x plus 2 and this x plus 2. Okay, now I'm realizing that both problems that I show you, almost everything cancels out. Okay, that doesn't usually happen. I guess I just happen to pick the two problems where most things cancel out. Okay, it's okay if nothing cancels out. It's okay if only one or two things cancel out. I'm not sure why I picked the exact two problems where a lot of things canceled out. All right, so I will multiply the numerators together. So on top I have 2 left. On the bottom I have negative 1 left, and 2 divided by negative 1 is negative 2. Okay, again, usually it'll have like a binomial or a rational expression left, but in these two cases I didn't. Okay, but the same process applies. You factor everything, you cancel common factors, and then you multiply numerators and denominators together the same way you do for fractions. Now, let's go back and talk about how you divide fractions. Okay? So, the way that we divide fractions is where we will, instead of dividing by a fraction, we're going to multiply by the reciprocal, okay? Where I will keep the first term the same, negative 1 over 5, Okay, I will multiply by the reciprocal of the second fraction, 4 over 7. Okay, sometimes this is called keep, change, flip. Okay, because you keep the first term, you change the sign from division to multiplication, and then you flip the second fraction. Okay, but you're multiplying by the reciprocal instead of dividing the fraction. Okay, and from there, we do the exact same thing as that we did for division, for multiplication. Okay, I can't do any cross-canceling here, so I now multiply the numerators together. -1 times 4 is -4, and the denominators together, 5 times 7 is 35, and this is the fraction that I get. Okay, in number 6, I will first rewrite this. I'll keep the first term. I'll change the sign and flip the second fraction over by multiplying by the reciprocal. I then notice that I can cancel off a common factor, the factor of 2. 2 goes into 2 one time, 2 goes into 4 two times, and then I multiply -1 times 2 is -2. 1 times 5 is 5. Okay? So we'll do the exact same thing for rational expressions, where we will keep, change, flip, anything we're dividing. I will cross cancel by canceling common factors and then multiply through. Let's look at some of those where we're dividing rational expressions. We'll start here with number 1. And the first thing that I'm going to do is I'm going to keep, change, flip, and multiply by the reciprocal. Okay, and so I'll rewrite this as 6x divided by 4x minus 16 times, so I'll change the sign from division to multiplication, and I'll flip over the fraction as x squared minus 16 divided by 4x. Okay, so instead of dividing, I'll multiply by the reciprocal. Okay, the second thing that we'll do is to factor the same thing we did before with multiplication. Now it's the same thing from here on. I will factor numerators and denominators. Okay, so I can't do a whole lot with 6x. That's just 6x. In the 4x minus 16, I have a GCF of 4. So I pull out the 4, and I'm left with x minus 4, and I have that. Okay, next I'm going to multiply. X squared minus 16 is a difference of squares. So I get, let's see here, x, two numbers that multiply to be 16 is 4 and 4, and so I get plus and minus for the difference of squares. Okay, I can't do a whole lot with 4x either. Okay, so I factored numerators and denominators. My next step is to cancel common factors. Okay, and this is the cross-canceling piece that we saw before. So x minus 4 cancel. Okay, now I want to be very clear about what I'm doing next. Okay, so what's left in the numerator is a 6 times x plus 4. Okay, so I see 3 factors in the numerator, and I will cancel off entire factors. Okay, I'm going to cancel off this x and this x, which is fine because that x by itself is an entire factor. Okay, what you cannot do is you can't cancel an x like this, okay, where I'm canceling off a piece of a factor. So that's not allowed, but you can cancel off an entire factor like x in the numerator and denominator. Okay, so just be very clear about that. Okay, the last thing, I'll just keep the same color, is that there's a 2 that goes into both 6 and 4. So I'll take out of the 6 and 4, 2 goes into 6 3 times, 2 goes into 4 2 times. Okay, and then the last thing that I'll do is I will rewrite, I'll just multiply the numerators and denominators together. Okay, I'll multiply straight across. 3 times x plus 4 is on top. And in the denominator, I have 4 times 2, which is 8. Okay, let's see one more of these of dividing rational expressions. Okay, we'll do number 4. So the first thing that I'll do is keep, change, flip. I will keep the first term as d plus c, and the bottom is c squared plus d squared. I will change the sign to be multiplication, and I'll flip the second fraction over and get d squared minus dc over c squared minus d squared. Okay, the next thing I'll do is I'll factor numerators and denominators. So in the numerator, I have, well, I'll rewrite this in alphabetical order, and I can switch the order because addition is commutative. So I have c plus d. Okay. In the denominator, I have, this is the sum of squares, and that can't be factored any simpler, like we have a difference of squares, but no sum of squares pattern for factoring. Times d squared minus dc, I see we have a GCF of d in both terms. Okay, so d times what is d squared, and that's d. D times what is minus dc, it's minus c. Okay, and then c squared minus d squared, I have the difference of squares, and what squared is c squared? It's c and c, and what squared is d squared? You get d, and you get plus and minus. Okay, now there's one more piece that I'm going to do that we saw a little bit earlier, having to do with this sign right here. This term, this factor, is in kind of a different order than I want to see it. And so I'm going to rewrite this, c plus d over c squared plus, d squared, times d times negative c plus d all over c plus d, c minus d. And so next I'll factor out this negative right here so that I can get it into c minus d format. So let me rewrite most of this. Okay, and by factoring out the negative, I get a negative d, and then what I'm left with is c, because that negative comes out, and then because the negative came out, it changes the other sign as well. It changes this sign as well to be a minus d. So that's in the format that I want, so I can cancel common factors. So that was quite a bit of factoring. I will now cancel common factors, and so c plus d and c plus d cancel. This c minus d and the c minus d cancel, okay? And that's all of my common factors. And so now I'll multiply them together, and I'm left with a negative d in the numerator and c squared plus d squared in the denominator. And that is dividing these rational expressions. This video is about multiplying and dividing rational expressions. Thank you for watching.